Welcome back to Cypress Academy PSoC 6 101. So far, we've created a BLE-controlled robotic arm and added a second PSoC 6 BLE Pioneer kit to the system to act as a remote control. The first version of the remote control wasn't exactly that exciting as it used UART keyboard commands. So let's make it a bit more interesting. We're now going to add CapSense capacitive sensing into our BLE remote control. So open up the remote control project from last time and open up the schematic. Now add the CapSense component. I think that we'll use the slider to move the robot arm, and we'll use the buttons to select which motor to move. Change the name to CapSense, then add a linear slider and two buttons. We'll use the two CapSense buttons in mutual cap mode, so change that setting. This board only has one transmit pin for the CapSense buttons, meaning they share the transmit pin. So go ahead to the Advanced tab, Widget Details, and change the button 1TX to be button 0TX. Okay, we just added a bunch of pins to our design. They're buried in the CapSense component, but we still need to assign them. So open up the DWR pins configuration window. Now assign the pins for the linear slider to be P83 through P87, button 0RX to be P81, and button 1 to be P82, then the button TX to P10. Then you assign the capacitors to their default locations. See, they're labeled in green when you do the pull-down menu. All right. Now, because I'm into code reuse, I'll copy the CapSense task.h and CapSense task.c from the main controller project. So expand the main controller project, then type Control-C to copy the .h file, then Control-V it into the header files of my remote control project. All right, now do the same thing to the CapSense task.c, except for it goes into the source files. Now that I have BLE task.h and c, and CapSense task.h.c, and UART task.h.c, let's go one by one and make sure they're all the things that we want. First, the UART. I still want to be able to send commands based on the keyboard, so I think I'll just leave it alone. Next, BLE task.h and c. We tested this earlier, and it seems to work just fine. In our CapSense tasks, I'm just going to call the right motor position function. Okay, so I don't need to change that either. Now the CapSense task files, they're going to be very similar to the main controller. First, CapSense task.h. Let's see here, that will be exactly the same. The only thing that it needs is a function prototype of the CapSense task, so that the main function can start up the CapSense task. Now, the CapSense task.c. Start with the includes. This task needs to know about the project.h, FreeRTOS.h, task.h, and BLE task.h. Let me do those includes. I'm going to use the right motor position function that I wrote in the last video, so I can delete all this stuff about PWM messages and all that jazz. Now look at how awesome this is. All I need to do is when there's a touch on the CapSense slider, I just take that number and call the right motor position. That's it. The last thing that has to happen is I need to start the CapSense task in the main. So I'll edit main_cm4, add the CapSense task.h include, and then call the task startup function. Sweet! All right, let's hit program. As soon as the programming is done, look how fast it connects. See, the red lights turn on. Those are LED 9. Okay, so now I run my finger on the slider back and forth and back and forth. Now press button 2 and see if we can run the other motor. Sure enough, this works really well. We're well on our way with this remote control. Now that we have a BLE remote control with CapSense and a BLE controlled robotic arm, for the next step, let's add in some sensors. For the next few videos, we'll be implementing the motion sensor and the e-ink display for the BLE remote control. As always, you can post your comments and questions in our PSoC 6 community, or you're welcome to email me at alan_hawse@cypress.com or tweet me at AskIoTExpert. And once again, thank you for your time.